We discussed about the normal distribution. It is also called as a symmetric distribution. In some cases, it is called as a bell curve, and some people they call it as a Gaussian distribution. Okay, what is so big deal about normal distribution, right? So the normal distribution, we know it is kind of a bell curve. Okay, the bell curve, and that is what your normal distribution. In the case of normal distribution, it can have any mean and a standard deviation. Okay, so we use the notation. Try to be familiar with this notation also. We use the notation. One second, just. We use a notation called the mu to represent the population mean. The mu is there here in the middle. Okay, this is what your mu, and this is your sigma. Okay, the standard deviation. Okay, this is what your mean. The mean is there in the middle, and this is what your one sigma, two sigma, and so on, right? So in the case of normal distribution, you can have any mean and a standard deviation. So it allows us. This one allows us. This one allows us to get shifted and scale to fit different data sets, right? So in the case of normal distribution, right? So you can have any mean and standard deviation. On the other hand, we have something else called standard normal distribution. This already I discussed, but I did not discuss it in detail. Okay, so what is the difference between standard normal distribution and the normal distribution? In the case of standard normal distribution, the standard distribution is fixed. Okay, so it always have a mean of 0. Your mean will be 0 always. Your mean will be always 0. And the standard deviation is going to be 1. Okay, this is the one is fixed in standard normal distribution. The mean and sigma is fixed always. Okay, so this one serves as a standardized reference for normal distribution. Okay, you might be wondering why the mu is 0 and sigma is equal to 1 in the case of standard normal distribution, why they need to make it fixed. Supposing somebody is asking you, what is the average sales last week in specific location of a retail store? Let's say you operate across 2,500 plus retail chains in USA. Okay, take for example Walmart and Target and all, right? They have 2,500 plus retail chains are there. If somebody is asking you what is the average sales, so it's very difficult to quantify, right? So let's say you can say 252K, so 252,000, 202 dot 202.35. It's a big number. Instead of using a big number, better you can use the mu equal to 0 or sigma equal to 1. In the case of standard normal distribution, this is how we'll be using it. Okay, and we have something called z-scores. We have something called z-score. It's a measure using which we can standardize the value from any normal distribution to the standard normal distribution. So we use a formula called z. We have something called z. Okay, the z is x minus mu divided by sigma. This is divided by sigma. Okay, this is what. Let me just write it again. So we have, in the case of standard normal distribution, this is what standard normal distribution. The mu is fixed and standard sigma represents standard deviation. Mu is for the population mean. So this is the one. Okay, it represents this. This is a fixed value in the case of standard normal distribution. Why? Like I said, in the case of normal distribution, it can take any value for your mean and standard deviation, but it is difficult to quantify in the case of huge, if the figures are too big. Okay, so what they did, the scientists in the past, they came up something like the standard normalization. They wanted to standardize this one. Okay, so as part of this, right, they came up with some fixed values. Mu is the always 0, and sigma is equal to 1. So 1 sigma above the mean, 2 sigma, 3 sigma. So 1 sigma below the mean, 2 sigma below the mean, 3 sigma below the mean. Right, that is how they want to quantify it. So they have come up with some formula for finding out the z value. So z is equivalent to, okay, what is the z score? So what is z? Z, right? In Americans, they use the pronounce z. Okay, z they pronounce is z. The z score is a measure. Z score is a measure to standardize a value from any normal distribution. Used to one second, I think I made a problem here. Okay, I think I'm audible, right? I got some message here. So z-score is a measure used to standardize, right? Standardize value from standardize the value from standardize the value from normal distribution to standard normal distribution. Z-score is a measure used to standardize the value from normal distributions. This is the one they use it. The formula for z-score is x minus mu divided by sigma. What is mu? Mu is the population mean. Sigma is the population standard deviation. Okay, so for this, we can work out with some kind of problems. Okay, for example, in a class of students, right, they took a math test, and the test scores follow a normal distribution. Let's say the mean of I'm going to say for 75, and then the standard deviation is going to be the standard deviation is 10. Okay, let us say the standard deviation is 10, and then the mean is this one, and then population. Okay, so sorry, let's say 85 is your mean, and then your population mean is 75. Let's say you one specific score value is 85. You scored 85. Okay, and or the mean, the x bar is the sample mean. The sample mean is something like one in a specific test, right? If you take average of students, right, 85 minus the population standard deviation. Sorry, the population mean is 75 divided by 10, and what value you get here? So here 10 divided by 10 is 1. Z equal to 1. This means this student score is 1 standard deviation above the mean. Okay, so they wanted to understand whether it is 1 standard above the mean, the sale is or the sale is 2 standard above the mean, or 3 standard above the mean. Basically, they want to, or is it 1 standard below the mean, or 1 standard deviation, 2 standard deviation below the mean. They want to understand this way. This is a simple example. Anyhow, I will give you some exercises. You can work on it. Next week, what we will do is we will have an in-class hands-on exercise. Okay, wherein we will, all of you have to contribute, practice it. Don't miss out the session. Attending the session is very much important. Again, punctual is also very important. Okay, if you join late, it is a problem. So what is the difference between standard normal distribution, or the normal distribution, and the standard normal distribution? The key differences: in the case of standard normal distribution, the mu, population mean, and standard deviation, these two are fixed. The population mean is 0 and the standard deviation is 1. Whereas in the case of normal distribution, the plain normal distribution, the mean can take any value and sigma can take any value. So why do they need to come up with an idea of the standard normal distribution? So they want to use some standardized reference for normal distribution. They want to use some standardized reference for normal distribution. Okay, for example, in the case of exam, they give you marks, right? They give you rank. So rank 1 means your performance is great. Your performance is great. Rank 1 means, your performance is great. Instead of saying that how much mark is scored in each subject, they standardize some reference, right? They standardize the reference for your, the position where you stand. Rank 1, you are falling in the rank 1. Let's say you are falling in the rank 1, and your friend is falling in rank 2. The same way, they standardize it with the rank. Similarly, here the z-scores are used to standardize the reference for normal distribution. Okay, so now you need to, this is the one you need to remember it.